there are two laws of refraction. Among them, the first one is same as the second law of reflection. Consider light traveling from some medium 1 to another medium 2, which is optically denser than medium 1. So its speed in medium 2 decreases and it bends towards the normal. The first law of refraction says that the incident ray, refracted ray and the normal at the point of incidence all lie in the same plane. It means that if I were to draw this on a piece of paper, they all will be on the plane of paper and not out of the paper. What about the second law? The second law is also called Snell's law of refraction. Snell's law gives us the relation between the incident and refraction angles and the refractive indices of the mediums. What is the refractive index of a medium? It is the extent to which the refractive medium increases or decreases the speed of light. Mathematically, it is the ratio of the speed of light in the incident medium to the speed of light in the refractive medium. It's denoted by n and the two numbers in the base are the two mediums. We read this as refractive index of medium 2 with respect to the incident medium 1. Also, V1 and V2 are speeds of light in medium 1 and 2 respectively. We can also define it as the extent to which light changes its direction in the refractive medium. Okay, let's discuss the Snell's law of refraction now. In simple words, it tells us that the ratio of the sine of the angle of incidence to the sine of the angle of refraction is equal to the refractive index of the second medium with respect to the first medium. Now look at the term on the right. It is constant for light of a given color and for the given pair of media. This is the basic idea of Snell's law, and there are different ways in which we can understand it. In the previous video, we'd seen what n/1 means. It is equal to the ratio of speed of light in the incident medium to the speed of light in the refractive medium. So we can also say that sine I over sine R is V1 over V2. There's yet another way to understand this. We may want to understand the ratio in terms of the absolute refractive indices of the medium. Absolute refractive index, if you remember, is the refractive index of a medium with respect to vacuum. For instance, if the refractive medium is water, then it's written like this. So can we find this ratio in terms of n1 and n2? Yes, we can. We just use some very basic math. We can write this ratio like this, where c is the speed of light in vacuum. Yes, if you simplify this ratio, we will get V1 over V2. And can you guess what the numerator and the denominator are equal to? That's right. This is nothing but the absolute refractive index of medium 2, and this is the absolute refractive index of medium 1. That was another way of understanding the Snell's law. We can also say that sine I over sine R is n2 over n1, where n2 and n1 are the absolute refractive indices of media 2 and 1 respectively. Hope you understood this well. Let's move on to a new page. So these were the two laws of refraction of light. In the next lesson, we will solve a simple example based on Snell's law.